Change the Q value because we tried that.
Okay, so in the software you can change the Q value, anything you want. So the logic is, let's go lower. When you do that, you'll notice that the amount of fragments you produce starts to drop off. Because you can envision that the trap is like a bowl, okay? The Q value is the depth of the bowl. So the higher the Q value, the deeper the bowl is. So when you shake the precursor and he fragments, and he creates product ions. If those product ions are light, they just roll right out of the bowl. The deeper the bowl, the less chance they kind of roll up the sides and roll back to the bottom eventually. Okay? So going higher, going lower loses our efficiency of fragmentation. Going higher creates this 1/3 rule or this half rule if you go really high. So we never cared about that because we said what the hell ions are down in the low mass range that you care about. And people were like, oh, we don't care, there's nothing down there. And then Waters, right? Or is it ABI or Waters? Who released iTrack?
Yeah, it's ABI. It's their Q track.
They released these compounds that you can label your mixtures with that produce distinct product ions. What, 1,9, 111, 113, 119 or something. Okay. Now, we called them the trap killer, because they were distinctly produced to fall within our 1/3 range right here. So we can't use them.
So couldn't you have come up with some kind of bigger thing that had some...
Thermo doesn't do chemistry. You'll notice we have never released any chemical products. Okay.
It drives instruments.
I don't know why we've never gotten into chemistry, but we refuse to get into that area. Okay. So, once iTrack came out, Jay Schwartz, our head scientist, he goes, everyone's complaining about this. He goes, well, it's a real simple problem that you just never asked me to look at. Okay. So Jay goes, the minute iTrack came out, he goes, oh, I have a simple application. What he does is he takes the ion up to a Q up here and he isolates it. Okay. And then he fragments it up there. So he brings it up and he fragments it right here. And he turns the energy on. Okay. But he only turns the energy on not for 30 milliseconds, he turns it on for 100 microseconds. Okay, and he brings the ion away from the center. Okay? In a quick pulse. And then, after that 100 microsecond up, he brings the ion all the way down to here. Okay? He does that so fast that the ion has not had a chance to fragment yet. So the ion's out here. Okay, and now it comes back to the center, and as it does that, it fragments. So he's up here to get his maximum efficiency. He's down here to capture all his product ions. And now we end up with the 1/26th rule, which Jay says if you need to go below 1/26th of your precursor M-overs, you need to get a life.
126, so about 1,200 down to
50. That should be more than enough, right? Okay. That's called pulsed Q dissociation. So we pulse the Q up, and we bring it back down. That
normally it's you're pulsing at a lower energy, like 0.25. So that
Q of 0.25. Right.
Okay.
Q is not energy.
Typically, it's not energy.
It's not energy. Don't think Q is energy.
Even though its units are in units of energy.
We call them collision energy because we can't come up with an appropriate word. Okay. Q is really frequency. But if you tell people you collide at different frequencies, they'll give you the classic look, which I always did all through graduate school. It's like, what's frequency? Okay, we had in the FT, I've been doing this for 15 years. To this day, I can't define what frequency of fragmentation does. I don't understand it as a physical thing. So we call it collision energy, even though it's not an energy. Going to a higher energy doesn't change the spectra.
So higher Q value is a higher frequency.
It's a higher frequency. What that means, that's hard. It really has to do with efficiency and what ions can we capture. So the Q really determines how efficiently do we capture the ions and which ions do we capture. Now, PQD is going to be released with LTQ Instrument Control 2.0 for Excalibur 2. Excalibur 2 was already released, but there's no software to control the LTQ. That will be released this fall. I don't know if this is a summer fall or if this is a cold winter fall. I'm not sure which it is. Okay.
So I could get 2.0, but I couldn't use the older instrument control software.
Right. Right. You can use 2.0, but you...
Just to analyze the data.
Right. You can analyze the data perfectly fine. Now, the big question for you guys I don't know yet is, what does that mean as far as Brayman software goes? I don't know if Brayman, which makes the FT part of the instrument, is going to release an instrument control that's based upon LTQ 2.0 at the same time LTQ does. Okay. Usually we find Brayman software is a little bit behind because they have to get the LTQ control from San Jose and then test it in Brayman to make sure it doesn't screw up because the LTQ communicates back and forth with the FT to do data dependency. Okay. Now, more importantly, unless it is absolutely critical to you, which it might be if you want to do eye track, I hate to be the first person with the instrument control. Okay. You probably want to be like, I always tell customers, you want to be about 2 months behind the release. Okay, just to see if we're going to do an SUR, a service update release, or a service pack, or a service. So we have S releases, SPs, and SURs, depending upon the severity, you know. A service pack is when you put the instrument, you know, something about our instrument San Jose was different than your instrument, and it just totally wiped your instrument unusable. Okay? Now I want you to be aware it can be a bit difficult to go backwards. Okay? Yeah, you got to nuke the computer and start again. I just want you to be aware.
We've already done that.
Oh, okay. Okay, that's some people. I have an undergrad degree in computer science. I don't care nuking computers. Other people are like, oh my God, I got to wipe the whole computer. Yes. Okay, end of LTQ. Do you have questions on the LTQ? Not the FT, the LTQ. The FTs now will be easy because once you understand the LTQ, you're going to find a lot of the concepts on the FT are very, very similar. Okay. It's a lot to absorb, but it is, unfortunately, you guys own the most complicated instrument we sell. I think it's actually fairly easy. What?
Orbitrap's too.
Yeah, but the Orbitrap is...
Because there's a multiplication factor involved. That's why I said don't look at absolute numbers if you have two different machines, because they no longer compare. They did up until the XP Plus. Once they went to this, because it was so much more sensitive, they said we're not going to do that multiplication factor anymore. The other main thing is injection waveforms. Have you ever worked with them? Basically, what you're trying to do, injection waveform is anything in here is held in the track, anything outside folds outside, and we'd like to see this. In real life, when you're looking at ions, it's like this. Now, if you've worked on earlier equipment bars, worked on a Deca or a Classic, there was a waveform A and a waveform B. Waveform A would drop out anything below the mass of interest. Waveform B would drop out anything above.
This is for selecting ions.
Right. And when you used to do it on the three-dimensional tracks, you lost sensitivity when you did this. This system, you don't lose sensitivity, because what they do is they actually force the peak in here. So you can actually run with this on and not lose sensitivity. Injection waveform. It's fitting this rear peak, forcing it into the actual square. Best fit.
So it has a better control of the field.
Yeah. Yeah. And there's no just trying to discriminate below or trying to discriminate above. It'll actually discriminate your peak out without losing sensitivity. So I normally tell people when you're setting up methods, leave it on. If you look like you're having trouble, turn it off and see if it makes a difference. Because you don't sacrifice sensitivity, it's always better to go with the theoretical field than to just let it run. And that will save with the tune file.
So this is, if I wanted to have more sensitivity and get more ions in there, I would read this value there. That's part of it.
Yes.
You have to be careful though, because
Too much is space charge.
and it's charge state,
Yes.
and it's charge state dependent. So like for whole proteins, you got to actually cut that down quite a bit to what the default level is.
And normally, these are default settings. If you ever want to know what the default settings are, you can actually hit reset. Reset will reset these to the actual factory defaults. These are the factory defaults for a standalone. When I'm doing an FT, I usually set this to 10,000 rather than 30,000. Only because the only thing I'm ever working with is this tune solution. This works good for me. For the FT, normally it's 5E5 or 1E6. can go higher or lower, depending on the student. Those are usually two things I'm looking at when I'm looking. You know, people say, what's a good target value? They start at 5v5 for full scan, 1e6 for sim, 25 for image. These are the default settings.
If you get too many in there, you'll see your math start to shift. So
Yeah,
you'll know that
you will get space charge and you will get shift. The volume in the linear track is bigger than the three-dimensional track, but you can still space charge in it. And the big thing people always go, well, there's not going to be any space charging in the FT, but it's still got to fill and count in the linear track first. And if you space charge in the linear track, what you're going to do is if you hit too high a target value here,